So this video is integrated 1, RFF for second semester, homework 2, okay? So see, this is dealing with sequences. Remember, we have arithmetic and we have geometric sequences. So let's take a look at this one. It says at the beginning. So this right here would be my 0 term is 1. At the beginning would be 0. At 1 minute, we have 5. At 2 minutes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like we are adding 4 each time. So that means it is arithmetic, okay, which is a linear type of graph. Okay, it's going to be a linear graph. Describe the pattern that you see in the sequence of figures above. Adding 4 dots each time, each minute. Assuming the sequence continues in the same way, how many dots are there at 3 minutes? Well, I would go 9, which is my last one, plus 4 is 13. So we'd have 13 dots. So that idea I just used is a recursive idea. Recursive idea. It's not my recursive equation, but it's a recursive idea. I took the term from before and added to get the next term. Okay, that's recursive idea. So now they're asking us how many dots are there at 100 minutes. So what I'm going to do is I'm actually going to skip to letter D and then come back to letter C, because letter D is asking me how many dots are there at T minutes. So I'm going to write an equation. So for this, I'm going to write it in 2 different forms, depending on how you like to write it. F of n or a sub n, okay? Or I shouldn't say of n, of t, they want t. So I could do f of t, where t is minutes, is equal to my start, okay? You always start with your start. And my start is 1. And what am I doing? I'm adding 4. Now, since I'm starting with my 0 term, this is important. This is your 0 term. Then this is just going to be n. If I had started with my first term, which was my 5, okay, which was my 5 here. Let me, okay, so if I had started with my first term, which was 5, I would have written that 5 plus 4, I'm still adding 4, but I don't do n, I do n minus 1, because this is my first term. I'm always going to go n minus whatever my term, okay? And actually, I shouldn't say n, I apologize. I'm used to doing n's. They wanted us to do t's. So this is going to be a t because they asked us to use t. And let me put t over here also. Okay. So I'm going to use my equation right here to figure out 100. So I'm basically finding f of 100 because I want 100 minutes. And so I'm going to go 1 plus 4 times 100, which is going to be 401. 401 dots. Okay, on this next one, so this is 0, and I have 3, okay? This is my 1, and I have 6. This is my, this is my 2 minutes, which is going to be, I've got 1, 2, 3 sets of 4, so that's going to be 12. My next one is 3 minutes, and I have 3 sets of 8, which is going to be 24. And what you'll notice is happening is every single time I'm timesing by 2, times by 2, times by 2, times by 2, And I'm assuming this one's going to be times by 2 also. Let's take a peek. So this is going to be 4. And I got 4 by 4. So I've got 16 times 3. 16 times 3, which is going to be 48. So yes, I was timesing by 2. Okay, so since I am doing that, timesing by 2, that is going to make this geometric. I'm just going to write it here, geometric. And geometric is going to be exponential type of a graph. Okay, describe what you see in the pattern above. So we are multiplying by 2 each time. Assuming the sequence continues in the same way, how many dots are there at 5 minutes? So I know at 4 minutes, there are 48. So I'm going to go 48 times 2. Again, this is a recursive idea where I take the term I know and I do what the pattern is, which is times by 2 to get the next term. Okay, so I could keep on doing that, times it by 2, times it by 2 to get whatever term I want, but sometimes it's so far away we want to come up with an explicit equation, which the one I had up here would be explicit. Okay, so when I do that, I get 96 dots. Write a recursive formula to describe how many dots there will be after t minutes, and then write an explicit. So recursive is going to be, I like to start with what I start with. If you don't know what you're starting with, the recursive doesn't help you because all recursive tells you is what you're doing. I'm adding or multiplying or something like that. And you don't know where to start. So you need to, with your recursive, say where you're going to start. So my f of 0 is 3. And then this is my recursive formula. If I want f of t, because they tell me t, I'm going to take the term before t, which is t minus 1, just like on letter B over here. To find 5 minutes, I used 4 minutes, okay? And then what am I doing? I am timesing by 2. Now, they could also write it like this. They could also do f of t is equal to 2 times f of t minus 1. That's also the same. Write an explicit formula. So explicit formula. I don't need to say f of 0 because I will have everything in my equation. So I'm going to go f of t is equal to, and if I know my 0, start with your 0. So I'm going to start with my 0, which is 3. What am I doing? I'm timesing by 2 and then to the power t. Now, again, if I did not know my 0 and I started somewhere else, so let's just say, as an example, I wanted to start with my 2 minutes. Let's say I knew 2 minutes and I knew from there on, I could do f of t is equal to my 2 minutes. I had 12 dots. So I'm starting with 12 at 2 minutes, still timesing by 2, but this would be t minus 2, just like I did t minus 1 on the problem above. Now, I'm just going to add a blank page onto this. And I want you to understand that in both of these cases, another way I could have done it is instead of writing it as, and so I'm going to be doing this here, instead of writing it as f of 0, a lot of times we use a, in integrated 3 we use a. You could do a sub 0 is equal to 3. That means the same thing. And then I would say a sub 0, or sorry, a sub 0, a sub t, or n, we use n, but they want t here, is equal to a sub t minus 1 times 2, or a sub t, let me start again. A sub t is equal to 2 times a sub t minus 1. If I'm going to write this one, I could write a sub t is equal to 3 times 2 to the power t. So putting it as a subscript, that subscript is telling you what term you're looking for. It's the same as having it in the parenthesis. And that's the end of this video.